Press the bell icon on the YouTube app and never miss another update.
Yeah, see the next one. So anyhow, for a square plate, except this center, remaining all are almost ma square by 12, and here ma square by 6. Now see, let us find moment of inertia at one end of the rod, and the rod makes an angle theta. See the question. Find moment of inertia about O as shown in figure. As shown in figure. See the given the diagram like this. Whose length is given L and the rod makes an angle theta. Target is about this axis. We have to find moment of inertia. Okay. Of course, this is also like a one ender. Okay. Now to solve this again, follow the same method. Take a small part, and this is a linear object. You have to take lambda, that is mass by length, and this part thickness is. Let us suppose the distance of x. The thickness of this is Vx, mass is dm, and see the distance from here to here. This is x cos theta component, and this is x sin theta. Perpendicular distance from the axis is x sin theta. And for small part, lambda we can write dm by what? Dx. So dm, directly we can write answer. So lambda dx. What is lambda? Mass by length dx. And see, this is the rod. Total length of the rod is given L. So apply the integration. So for small part, dA is equals to dm into perpendicular distance. What is perpendicular distance? X sin theta. Perpendicular distance is x sin theta. And apply the integration from 0 to L. This is I. Okay. So 0 to L, dm is m by L dx, and x sin theta square. Sin theta is a constant, m by L sin theta, and x square, the sin square will come out, x square dx means x cube by 3, 0 to L. So L cube by 3, 1 L gets cancelled, m L square by 3 sin square theta. Of course, we can expect this answer directly. At one end of the rod, we have a formula ml square by 3, and here L is the length, and from here to here how much? L sin theta. So ml square by 3, m L square by 3, m L square by 3 means L square sin square theta by 3. Direct final answer we will get. Okay, so ml square by 3 sin square theta is the required answer for this question. Okay, now let us move on to the circular ring. So let us find moment of inertia of the circular ring. Circular ring, circular disc, solid cone, hollow, everything will come. So let me continue all. So the second object I am finding here, circular ring. So let me find first one, about an axis, passing through center, perpendicular to the plane. So take a circular ring and axis passing through center, perpendicular to the plane. So this is the circular ring, and this is the axis whose mass is m. This mass is m, and r is the radius. So if I take any small part whose mass is dm, then you will get directly moment of inertia dA is equals to dm into r square. If you apply integration, directly we can expect mr square. Okay, this is the axis passing through center, perpendicular to the plane of the ring. I think you know plane of the ring like that. So mr square is the regular formula. Okay. And next let us find about a diameter. Okay, on board all diagrams are planar diagrams. So about a diameter, let me find. Second formula, about a diameter line. So about a diametrical line. See, this is the ring whose radius is r. Okay, so let us suppose, see, this is the ring, and this is the axis passing through center perpendicular to the plane. See, this is the plane. Okay, next about the diameter. See, this is the diametrical line, and this is also one diametrical line. Let us suppose one is IX line, other one is IY line. Okay, one is IX, other one is IY, and this one is IZ. IZ already we have first formula. This is IZ. Feel that this is IZ. So let us imagine this is the IX on board. This is IX, and this is IY. The middle one is IZ. So the middle one is IZ, like this. IZ. IZ already we have a formula mr square. IX is the diametrical line. IY is the diametrical line. So due to symmetry, these two are same. Let us suppose this is I, this is I. Target is this only. From perpendicular axis theorem, IX plus IY, I plus I. IZ is first formula. Perpendicular to the plane, first one, perpendicular to the plane. Mr square 2I, then what? Mr square by 2. So moment of inertia of a ring about any diameter is mr square by 2. Easy. Okay. And next, let us draw the tangents for both. Let us draw the tangent for first one, tangents for the second one. Tangent means, let me draw tangent like this. About this mr square, about a tangent perpendicular to the plane. See, this is the plane. So this is the mr square. Now let me find about this tangential line. Tangent perpendicular to the plane of the ring. Third formula, tangent perpendicular to the plane of the ring, plane of circular ring. So on both diagrams are same. So this is the tangent. About this center we have a formula mr square. This is center of mass. Moment of inertia passing through center of mass is mr square. This distance is r. Use parallel axis theorem. So I is equal to ICM plus mr square. ICM is what? This is ICM. Mr square plus mr square. This gap m into this one. Now answer is 2mr square. So about a tangent perpendicular to the plane is 2mr square. Then you draw tangent for diametrical line. See, this is the diameter. Okay, any one line. This is the diametrical line. You draw one tangent like this. About this we have a formula mr square by 2. And see, use parallel axis theorem. These two axes are parallel to each other. About this mr square by 2 plus mr square. Mr square by 2 plus mr square. So the third one, tangent in its plane. Tangent in its plane. See, this is the plane. Tangent in its plane. And this line is clear. Mr square by 2, center of mass. Axis passing through center, nothing but mr square by 2. If it is like this, mr square. Okay. Now mr square by 2 plus gap. So I is equal to mr square by 2 plus mr square 3 by 2 mr square. This is somewhat easy. Okay. So 3 by 2 mr square. First, suppose if they given any arc. Okay. So if they given any arc that makes something angle theta at the center of a circle, and if it rotates, then it will form as a circle. If they given any small arc whose mass is m, if they given whose radius is r, for that moment of inertia perpendicular to the plane passing through center is only this. Okay, because if the small arc is rotate, that small arc will complete a circle. Once the arc rotates, once any small arc rotates, the arc completes a circle. So the moment of inertia again equivalent to what? circular ring only. So mr square. And here tangent perpendicular to plane, tangent in its plane. Once we know moment of inertia, we can find radius of gyration by using k is equal to root of I by m. Okay. Now let us find moment of inertia of circular disc. Circular disc. Okay, this is linear object. Circular disc is aerial. So use sigma to find square plate and circular disc. Now the target is moment of inertia of circular plate, circular disc, otherwise circular plate, whose radius is r. Let me find first about an axis. About an axis passing through center, passing through center perpendicular to the plane of that disc. Okay, so this is the disc. Okay, whose radius is r, whose mass is m. Okay, and this will have some surface density sigma. If capital R is the radius, then sigma is equal to what? Mass by area. Area is pi r square. If I take any small part from this center, take a small part. See, this is the small part. I am taking a distance of something x. Take a small part whose thickness is dx. Okay. So this part will have mass dm. Then sigma is equal to, for small part, dm by what? dA. For small part, you find mass of that small part. Apply the integration. You will get the answers. So dm is equals to sigma dA. Sigma, what is sigma? M by pi r square. Area of that small part. Take that small part outside and cut and you place on its surface. Okay, this small part you take outside. Find out the area of that small part. That small part, length of that small part is, because that small part have, the small part is like a ring. That ring have length and thickness. That length and thickness will give area. So length of this small part is 2 pi x and thickness of that dx. So this is the area of the shaded region. So this is the shaded part. Area of the shaded part is length and thickness. Length is 2 pi x and dx. Okay, now you can strike off pi and pi. You will get mass 2 m x dx by r square. So I got the small part. Then I want to get complete moment of inertia, means apply the integrations. So dm, small part is like a ring, then use ring moment of inertia formula. Ring moment of inertia mr square. Dm into r square. R square nothing but x square. Limits are 0 to r. 0 to last one is r. This is I. Okay, dm means 2m by r square x dx into x square. So 0 to r. So if you are good in integration, then this is not a problem if you are convenient in integrations. Otherwise, try to simplify like this. 2m by r square x square. Integration of x square is x cubed by 3. Sorry. Already x square, total x cube. X cube derivative integration is x to the power of 4 by 4. X to the power of 4 by 4, 0 to r. Substitute upper limit and minus lower limit. So moment of inertia, you will get 2m by r square. This is r power 4 by 4, then we are getting moment of inertia is what? mr square by 2, means half of the ring, like that. So moment of inertia of the circular disc passing through center perpendicular to the plane of the disc is mr square by 2. So keep formula in mind especially. Okay, mr square by 2. And see, this is the area level objects. So I am taking a small part, I am applying integration, then I am getting answer. Okay, practice like this. Okay, this method will help to find some other type of questions. Okay, and let us find the next one. About a diameter. Okay, see, this is the axis passing through center perpendicular to the plane of the disc. Let me find about a diameter. So second one, about an axis, or otherwise about a diameter. So diameter means there are two lines, two diametrical lines, about a diameter. See, this is one axis, Ix, this is another axis, Iy, and this just now calculated Iz is mr square by 2, Iz perpendicular to the plane. Due to symmetry, let us take these two are equal. Suppose these are equal because of symmetry. Then use perpendicular axis theorem. This can be written as Ix plus Iy, I plus I. This is mr square by 2. Capital or smaller, that's not a problem. So 2I, then moment of inertia is mr square by 4. Earlier mr square by 2, now mr square by 4. Then you draw the tangents for first case and for second case. For first case is passing through center perpendicular to the plane. This one is mr square by 2. It's not a ring, disc I am taking, okay? And about a tangent. About a tangent means about this mr square by 2, about a tangent mr square by 2 plus mr square. So third formula of this one is about a tangent perpendicular to the plane of the disc. Perpendicular to the plane of disc. About this mr square by 2, about a tangent. This one I want. This gap is R, capital. That's not a problem. So capital, you take one, anyone. Okay. So use parallax theorem, ICM plus m into gap square. Gap is R. So ICM r square by 2 r square. So 3 by 2 mr square. Okay. So this is axis, means about a tangent perpendicular to the plane of the disc. Now you draw the tangent for the diametrical line. Okay. So tangent in its plane. Keep words in mind. Tangent in its plane. Okay. Feel that again. If it is a disc, tangent. So this one is mr square by 2. Okay, sorry, about diameter. Diameter is what? Diameter is mr square by 4. So this is r square by 4. I want to get about this. This is again r. Okay. So use parallax theorem. R square by 4 plus r square 5 by 4 r square. In the same manner, if they given any small piece of the disc, any small piece is given like this, like a pizza piece, okay, like a bread piece. So if they given a small piece, if it is rotated about this axis, again this also forms a circular disc passing through center perpendicular to the plane. Again formula for this is same, mr squared by 2. If you want, again follow the same method. If r is the radius, take a small part at a distance of something x. This is a dx. Take an angle theta. Take a small part mass. Apply the integration from 0 to capital R or 0 to whatever may be the radius. So you will get the answer mr squared by 2. Okay, use some sector area, m by area, r square theta by 2. Sector area, half r square theta. So, for this sigma, mass by area means what? R square theta by 2. If you use 2m by r square theta, this is sigma. For small part, again, okay, for small part again, sigma is equals to dm by dA. So dm is equals to sigma dA, sigma 2m by sector area written r square theta, this dA, arc length, r theta, okay, if this, sorry, x theta into dx. Again multiply into something gap x square, x, theta, theta. So this is dm. dA is equal to what? dm into x square. dm, in a dm one x is there. Here one x square is there. X cube. Apply the limits 0 to r. X cube, x power 4 by 4. We will get the answer. Okay. So for this small part, half disc, quadrant of a disc, if any small piece of a disc, if that disc rotates about its own axis, then moment of inertia is mr square by 2. Okay. Let us continue. Moment of inertia of hollow sphere. So keep the final formulas in mind, practice all these formulas and solve some easy level of questions by using the basic formulas. Now let me continue. Moment of inertia of a hollow sphere about its own axis or about a diameter. Whatever will be the line passing through center, that is a diametrical line. About a diameter or about its own axis. Own axis nothing but passing through center. Yeah, see now. So hollow sphere, inside is empty. Okay. So see, this is the hollow sphere whose radius capital R, whose radius is R. Hollow sphere have sigma. So mass by area of the hollow sphere. Area of the hollow sphere is 4 pi r square. Mass by area. Take a small part. Take a small part. About this we need to find. Take a small part. So if I take this small part have mass. That small part have mass dm, and this is r. Let us suppose this is theta. The thickness is very clear. R and d theta arc length, angle in radius. Okay, this is nothing empty space actually. If this part I taken from the inside, this part also covers. Yeah, you imagine correctly. So this region, you see from the top view, if I take a small part in this side, the top view is like a circle. Okay, the top view like some circle. So you will get some top view. If I observe from top view, the top view is like this. The thickness is something dx, and here this is r, and this radius is what? R cos theta, and this is r sin theta. Okay, r sin theta. Okay, see, this one is what? R cos theta, r sin theta, and this is r sin theta radius, and this thickness is what? R d theta, and this mass is what? dm. Okay, so sigma is equal to, for small part, dm by what? dA. So dm is equals to, let me write here, dm is equals to sigma dA. dm is equal to sigma dA. dm is equal to, what is sigma? Sigma is m by 4 pi r square. dA, area of this ring, length of the ring and thickness. Length is what? 2 pi r. R nothing but r sin theta. So 2 pi r sin theta is the length, circumference, into r d theta. So r square r cancel. 2 pi, this is 2 r. So what is dm? I am getting m by 2 sin theta d theta. So I am getting small point of mass is how much? M by 2 sin theta d theta. Now target is to find out moment of inertia. dA is equals to, okay, dm into ring. So dm into gap is how much? dm into this gap. Perpendicular distance is, this is the perpendicular distance, r sin theta square. Okay, and limits, this is 0, 0 r. Sorry. So if I take right side part, left side part also covers. So from here to here. So limits are 0 to pi because d theta is there. So I is equals to 0 to pi. What is dm? M by 2 sin theta. M by 2 sin theta r square sin square theta. Sorry, m by 2 sin theta d theta r square sin square theta. So m r square by 2 0 to pi sin cube theta d theta. So use some integrations, you will get the answer. Sin cube theta d theta. So let me extend this one. So let me write m r square by 2 sin cube theta. Let me write like this: 0 to pi sin square theta into sin theta. Sin cube theta we can write it as sin square theta into sin theta. Sin square theta, let me write 1 minus cos square theta. 1 minus cos square theta sin theta d theta. So use some substitution methods in integrations. Okay, substitution method means let us take cos theta something t, some putting method, substitution methods. Apply derivative for this. This is minus sin theta d theta, which is equals to dt. So sin theta d theta is equal to minus dt. Sin theta d theta is equals to minus dt. Take minus here. So we will get, let me write. So take this one. So let me write here. So I am rubbing this side. So use I is equals to mr square by 2 0 to pi. I am using this step. 0 to pi 1 minus cos square theta, nothing but 1 minus t square. Sin theta d theta, nothing but minus dt. Minus you write in front. Minus m r square by 2 0 to pi 1 into dt. This is a dt. Okay. So let me write like this. 1 minus t square dt. So I is equals to minus mr square by 2. 1 dt is t. T square is t cube by 3. 0 to pi. But what is t? mr square by 2. T is cos theta. Cos cube theta by 3. 0 to pi. Substitute pi in these two terms. Cos 180 minus 1. And after that minus of cos 0 and cos 0. Cos 0 also 1. So substitute these values, you will get minus 4 by 6 you will get. So I minus 1 by minus is possible here. Just you substitute upper limit in 2 parts minus lower limits in these two. You will get finally 2 by 3 m r square. Just you substitute the limits, upper limits minus lower limits. Cos 180 minus 1. Cos 0 1. You will get 2 by 3 m r square. So some lengthy, better focus more on formula, otherwise better you see the method, These methods will helps in finding some other type of questions. Okay, so take this. So 2 by 3 mr square. This is about one axis. Now let me find about a tangent. About a tangent. Hollow sphere about one axis is how much you are getting? 2 by 3 mr square. Now about this I want. About a tangent. About a tangent. So about a tangent is nothing but ICM plus mr square. What is ICM? Passing through center is 2 by 3 mr square plus mr square 5 by 3 mr square. Once you know moment of inertia, we can find radius of gyration by using k is equal to root of I by m. Now let us find moment of inertia of the solid sphere. Solid sphere about the diameter. Okay, whatever is the line passing through center is nothing but a diametrical line. So, about a diameter or about its own axis. Own axis also correct. Solid sphere, nothing but that will have some volume mass density. So, this is a solid sphere, like a watermelon. Whose radius, let us take capital R, and rho is the volume mass density. So rho is equal to mass by volume. Rho is equal to mass by volume of the sphere is 4 by 3 pi r cube 3m 4 pi r cube. For small part, dm by d means I am going to take some small part like this. If I take a small part, at a distance of something x, this is a dx. Small part. So dm is equals to rho dv. So dm is equals to rho, we got 3m by what? 4 pi r cube. dv, volume of this region. Okay, this is not a ring, it's not a disc. Okay, entire part you cut it, entire part. Only this part, that is nothing but like a hollow sphere. Okay, this is the small part. If you take out, that small part is like a hollow sphere. Okay, that hollow sphere will have some area. So area of that one is 4 pi x square, thickness dx. Okay, so 4 pi x square, thickness is dx. Now the mass of that part is r cube x square dx. This is the mass. And moment of inertia due to the small part is dA is equals to, I am writing dm into x square. I am multiplying 2 by 3. Why? Because small part is like what? Moment of inertia of the small part. Small part is like a hollow sphere. Hollow sphere about its own axis formula 2 by 3 mr square. 2 by 3 m nothing but dm. R nothing but x. Okay. And substitute the limits. This is I 0 to r. Right, 2 by 3 outside. dm 3m by r square, 3m by r cube x square dx x square. So 3 gets cancelled. 2m by r cube x square x power 4 x power 4 dx x power 5 by 5. Limits 0 to r, 2m by r cube r power 5 by 5, so 2 by 5 m r square. So keep the formula in mind, 2 by 5 m r square. Moment of inertia of the solid sphere about its own axis is 2 by 5 m r square. Okay, and about a tangent, just you use parallaxis theorem, you will get about a tangent. See, about a tangent, see this is the solid sphere, about this 2 by 5 m r square, about this means about a tangent. About a tangent is I is equal to ICM plus m r square. ICM 2 by 5 m r square, m r square 7 by 5 m r square. Okay. Okay, right. We do next one. Moment of inertia of solid cylinder. Solid, nothing but again volume, mass, density will be there. Moment of inertia of solid cylinder. Solid cylinder of length L, radius R, and I am finding about an axis passing through center, perpendicular to the length of the cylinder, perpendicular to the length of the cylinder. See, this is the cylinder. Okay, and this is solid cylinder, means complete material will be there. And I am finding moment of inertia like this, about this. L is the length. See, this is looks like a rod. Okay, and this is radius R. This looks like a rod. Okay, then you find. Anyhow, let us check first what is rho. Mass by volume, volume of the cylinder, pi r square h. Pi r square h nothing but L. And from this center, you take a small part. See, this is the small part. I am cutting a small piece. See how that small piece looks. That small piece looks like what? Disc. Whose radius is R. That small piece, if I cut, that is like a disc. And this is the disc. And the axis passing, see, this is the disc. Axis passing like this, nothing but what? It is the diametrical line. This is the diametrical line. Okay, this is passing through center perpendicular to the plane. Now the disc is like this. Disc is in this way. Okay. About the diameter formula m r square by 4. Okay, axis passing through diameter of the disc is m r square by 4. Use that formula. Okay. And this is at a distance of x. Take a small part of dx, small mass is what? Dm. So for small part, dm by what? dv. So dm is equals to rho dv. Rho m by pi r square L dv. Volume of this one is what? Area of the disc pi r square. thickness of the disc dx. Pi cancels. So you are getting m by l dx like a rod. You are getting like a rod, m by l dx. Just verify the rod concept as it is. And the moment of inertia due to the small quantities. Okay, due to the small quantities, I am using parallel axis theorem to find this one. This gap is x. Moment of inertia passing through center of mass plus mass into distance. dm is the small mass into distance. And this di is equals to moment of inertia passing through center of mass is what? dm into r square by 4. mr square by 4. This is mr square by 4. Disc diameter. Okay. Axis passing through the diameter. Diameter of the disc is mr square by 4 plus dm into this gap. Okay. Our target is to find out this one. I is equal to ICM plus mx square. M nothing but dm. Okay. dm x square. Apply the integration. Okay. Limits are very clear. Minus L by 2 to plus L by 2. Right side L by 2, left side minus L by 2. This is I. dm. What is dm? M by L dx. Minus L by 2 plus L by 2 m by L dx r square by 4. Let me multiple integration. Minus L by 2 plus L by 2 m by L dx x square. So here everything is constant except dx. M r square by 4 into L 4L. Integration of dx is x minus L by 2. You apply the integrations. Minus L by 2 to plus L by 2. Plus m by L is outside. X square is x cube by 3. Apply the integration properly. L by 2 to plus L by 2. This is L by 2 minus L by 2. Minus of minus plus. This is L. L cancel. L cancel here. Substitute the limits. Here L by 2 cube, L by 2 cube. You will get ml square by 12. So let me write here directly. I is equals to m r square by 4 m l square by 12. So if you take m out, r square by 4, let me write first L square. Of course, no problem, L square by 12, otherwise r square by 4. It's not a problem. So the final answer for this one is m of L square by 12 plus extra r square by 4. Okay, ml square by 12 plus mr square by 4. So this is the moment of inertia of the solid cylinder about an axis passing through center perpendicular to the length. Okay, here just you substitute upper limit and lower limit, you will get this answer. Verify these calculations. Okay. Let me find moment of inertia about its own axis. About its own axis. See the next formula, about its own axis, like this. This is the solid cylinder. About its own axis. Now the cylinder is rotating like this. If I cut a small piece, if you take out, that small piece looks like circular disc. For circular disc, axis passing through center perpendicular to the plane of the disc, formula mr square by 2. Now here also same. Keep the formula in mind, mr square by 2 about its own axis. So for solid cylinder, about its own axis formula is similar to circular disc, axis passing through center perpendicular to the plane of the disc. Okay. Let us continue the same process for hollow cylinder. Continue the same process as it is process for hollow cylinder. So let me give some integration steps and you try to do that. Hollow cylinder. Axis passing through center perpendicular to the length. Same process. Axis passing through center perpendicular to length. So same process you apply, like how I did for solid cylinder. You follow the same process for hollow cylinder. You try this. Length is L, Radius is r. Take a small part. Small part is looks like a ring. Earlier small part is like a disc because solid. Now this is what? Inside is empty. Area level. So you will get some sigma. Tell me. Sigma is equals to. So mass and this one is see. Hollow cylinder. So hollow cylinder formula 2 pi RL. 2 pi RL. If I take a small part mass is a dm, thickness is a dx, and r is radius, and this is ICM. ICM is equals to what? dm into. So ICM nothing but about the diameter. About the diameter, ring about diameter formula, mr square by 2. This is about diametrical line. This is the ring and this is diametrical line. Diameter, about diameter mr square by 2. Okay, I'll write later. And for small part, dm is equals to sigma dA. What is dm? m by 2 pi RL. dA is 2 pi r into dx. 2 pi r gets cancelled. Again you will get the same m by l dx like previous. Now the moment of inertia due to small part is, so ICM plus mr square. So ICM nothing but dm into r square by 2 about diameter. This is about diameter plus dm into x square. Apply the integration from minus l by 2 to plus l by 2. Substitute this dm and apply the integration. You will get l square by 12 r square by 2 you will get. Just I am missing 2 steps. You try this. Okay. Follow the same process like a previous concept. Okay. Okay, here I am missing 2 steps. Try to solve this at least. Substitute this dm and substitute the integrations with the limits. You will get the answers. L square by 12 plus r square by 2 m into m. Okay. And about its own axis. About its own axis like this. If you cut this small part, that small part is like a ring. For this ring, passing through center perpendicular to the plane. Passing through center perpendicular to the plane is mr square. So for this ring formula, mr square, keep in mind about its own axis mr square. Now let me continue one more good question. Solid cone about its own axis. So verify this integration, you will get this answer. Write the next one. Solid cone about its own axis. About its own axis. See. See, this is the solid cone. Like a cone with beam. So this is solid cone whose radius is r and height h. About this axis I want to find. See, first you identify whether this one is a aerial or volumetric. So anyhow, solid object means volume. We will have some volume density. So rho is equal to mass by volume. Volume of this one is 1 by 3 pi r square h. So rho is equal to what? 3m by pi r square h. Again, to solve this type of questions, at a distance of something y, you take a small part. Cut the small part, we have some radius r. That small part is looks like a disc, circular disc. Okay? And this is at a height of h minus y. If this is h minus y. Okay? And this part we have mass dm, thickness is how much? dy, mass how much? dm. So for small part, dm by dv, dm is equals to rho dv, rho is 3m by pi r square h dv, area of the disc, pi small r square, thickness is dy. Okay. So area of the disc is pi small r square, that is a circular disc, pi r square dy. Okay. And see some different terms are there, r and y. Then let us we will do one thing, whether we convert r into dy or y into r, any one thing. To convert this, let us use the triangle system. See, this is one triangle, one more triangle. Compare the side by side, base by base. So let us get, let me write like this: small r by capital R, small height h minus y by capital H. Let us convert r into y, otherwise y into r, any one thing. Then we do one thing: h r, h minus y into r. Apply derivative. This is h into dr. H is a constant, y is variable. So minus dy into r. Just apply the derivative on both sides. H is a constant, dr, and this is 0. So minus dy into r. Let me write dr. Otherwise, so dy is equals to minus h by capital R dr. If I substitute dy in terms of dr, yeah, you will get the answer. So dy is equals to minus h by r dr. Okay, is it dy is equal to minus h by r dr. Yeah. So di is equals to, okay, disc. Okay, disc axis passing through center perpendicular to the plane. dm into r square by 2. Okay, so dm into r square by 2. What is dm? Substitute dm and limits very clear. Here r above is 0, r to 0. So let me substitute here. R to 0. What is dm? 3m pi r square. Pi gets cancelled. R square h. R square dy into r square all divided by 2. So 3m by 2 r square h. R square r power 4 r 0 r power 4 into dy. Substitute dy value minus h by r dr. h minus 3 by 2 m by r square r power 4. Here one more r is missing. H by this r is there. R cube r power 4 dr minus 3 by 2 m r cube r power 5 by 5 after integrations. So, and if you substitute of 0 minus, this one is minus, so minus plus, so you will get 3 by 10 m r square. Yeah, this is the required answer. 3 by 10 m r square. Okay, so I'm getting finally moment of inertia of a solid cone about its own axis is 3 by 10 m r square. See, from the starting onwards, just I started linear objects, surface objects and volumetric. For a linear object, I have taken rectangular rod. Rectangular rod perpendicular to length is ml square by 12. Perpendicular to breadth, mb square by 12. Perpendicular to the plane, ml square plus b square by 12. And next one end of the rod, ml square by 3. If it makes an angle, ml square sin square theta by 3. Okay. Next, later we enter into circular ring. For a ring passing through center perpendicular to the plane, for a ring passing through center perpendicular to the plane, mr square, diameter mr square by 2 half. About a tangent perpendicular to the plane, mr square plus mr square, 2mr square, and about a tangent in its plane, mr square by 2 plus mr square. Okay. Later, circular disc passing through center perpendicular to the plane, mr square by 2, about diameter mr square by 4 half, mr square by 2, mr square by 4. Next, tangent mr square by 2 plus mr square, tangent in its plane, mr square by 4, tangent in its plane, mr square by 4 plus mr square, 5 by 4 mr square. Later, we covered solid sphere, 2 by 5 mr square about its own axis, and about a tangent 2 by 5 mr square plus mr square. Solid is 2 by 5, so total 7 by 5 mr square. Hollow sphere 2 by 3 mr square. Okay, so 2 by 3 mr square, and about a tangent 2 by 3 mr square plus mr square. Keep all the values in mind. Okay. And later, solid cylinder, ml square by 12, like a rod, ml square by 12, solid cylinder, r square by 4. Okay. Hollow cylinder, ml square by 12 plus r square by 2. Okay, m of l square by 12 plus r square by 2. Solid cone, 3 by 10 mr square. If they given hollow cone, okay, this is also possible. See, this is the hollow cone. See, take a paper in terms of hollow shape. Okay, like this. And if you apply force like this, then this piece will join at the center. If I apply force here, this piece will come here, next piece will come here. So you will get some disc. Okay, take a hollow cone without trim. Take a hollow cone and apply force on it. Then that above piece will join at the center, next one join at the next level. So the total downside piece looks like a circular disc. So use the circular disc formula. Circular disc passing through center perpendicular to the plane is what? Mr square by 2. So for a hollow cone, about its own axis is equivalent to circular disc. So mr square by 2. So just apply force, and this is like a circular disc or like a circular plate. For a circular plate, we have a formula mr square by 2. So hollow cone, moment of inertia about its own axis formula mr square by 2. Okay. So remember all these formulas. Okay. If you are good in integration, definitely you are going to enjoy this one. Otherwise, at least practice the formulas. Okay. And these methods will help in solving some high level of questions. So practice all these methods. Next we will continue some more good questions, moment of inertia and cavity problem.